AI compliance is not about collecting regulations. It is about connecting each AI use case to real obligations, risks, controls, and evidence. In this course, you'll learn how to turn that connection into audit-ready governance artifacts. Think of this course as a guided build. We begin with core AI risk concepts, then map them to HIPAA, GDPR, and NIST. By the end, you'll produce a practical capstone that includes scope, controls, evidence, and remediation. The course follows a practical sequence. First, define the AI system, its data flows, and who may be affected. From there, you can identify the legal duties, security expectations, and risk scenarios that actually matter. Those risks become controls, procedures, and operating checks. Finally, you collect evidence and report governance in a form auditors and leaders can use. The key idea is simple. Context comes before compliance, and evidence proves execution. Choose the learning path that fits where you are today. If you're new to AI compliance, move through the course in order and give the foundations time to land. If you're intermediate, focus closely on the modules tied to your current project. If you're advanced, use the course as a reference. Most important, learn actively. Watch, map, document, review, save templates, discuss examples, and ask questions as you build. AI compliance mapping is a route, not a one-time checklist. We start by discovering how AI is actually being used. Then we connect each use case to obligations, risks, controls, daily processes, and the evidence auditors will expect. Repeatability is the goal. Legal, privacy, security, engineering, product, and governance teams all contribute to the same map, so compliance becomes an operating model instead of a last-minute scramble. Problems appear when each team manages its own piece in isolation. Legal tracks regulations, engineering changes models and prompts, security monitors risk, and compliance gathers evidence later. A life cycle connects those activities. As the system changes, obligations are translated into controls, controls are monitored, and evidence is collected continuously. That keeps compliance aligned with real AI operations. Compliance mapping starts by drawing the box around the AI system. Define the business purpose, user groups, boundaries, and where the system will run. Then inventory the data: PI, personal data, sensitive categories, logs, prompts, outputs, embeddings, and training data. Next, ask how the system affects decisions. Does it assist, influence, or automate? Finally, connect that scope to jurisdictions, regulators, contracts, and internal policies. Bad scope creates bad mapping. Once scope is clear, mapping turns abstract requirements into something testable. Start with the obligation, such as a GDPR access or deletion, right? Then ask how that obligation could fail inside an AI workflow, like incomplete deletion from training data or retrieval systems. From there, define the control objective. Choose the safeguard and embed it in an operational process. The final output is evidence: tickets, logs, approvals, or reports an auditor can inspect. AI compliance works when ownership is shared, but not blurred. Legal and privacy translate regulations into requirements. Security and GRC turn those requirements into safeguards, monitoring, and evidence. Product, engineering, and data science explain how the system behaves, where data moves, and which controls are feasible. Executives and governance leaders make the risk decisions: who owns them, what gets funded, and what residual risk is acceptable. The life cycle connects those responsibilities into one accountable system. Compliance becomes real when it leaves policy documents and turns into artifacts teams can inspect. Matrices connect obligations to controls, owners, and evidence. Risk registers and model cards explain what the AI system does, where it can fail, and how risks are managed. DPIs, audit logs, and repositories preserve traceability. Playbooks and vendor questionnaires prepare the organization for incidents and third-party scrutiny. Together, these artifacts bridge governance intent, technical execution, and audit readiness. A practical map also needs concrete failure scenarios. Start with data. Could the system expose PHI, retain personal data too long, or memorize sensitive content? Then look at model behavior. Could it hallucinate, discriminate, or produce unsafe recommendations? Add operational risks such as weak monitoring, unclear ownership, poor vendor oversight, or no incident process. Each scenario is then mapped to the applicable regulation, required control, accountable owner, and evidence needed to prove compliance. Begin with the risk scenario, not a control wish list. For example, a prompt may contain PHI. The control objective is the outcome we need: prevent unauthorized disclosure and protect patient data. Then design controls that make that outcome real, such as IAM, encryption, filtering, logging, and monitoring, supported by policies, approvals, training, and vendor review. Finally, assign an owner, define a test method, and keep evidence so the control is auditable. Audit readiness starts long before an auditor asks questions. For each obligation, collect evidence showing that the control exists, is implemented, and works over time. In AI, that includes technical proof, such as logs, alerts, test results, and architecture records, plus governance proof, such as policies, model reviews, DPIAs, incident records, and vendor documentation. Tag each item by owner, date, control, and review status. A clean repository turns audits into verification, not archaeology. The lifecycle is how AI compliance runs every day, not a project that ends at launch. Design choices, development changes, deployment decisions, monitoring signals, and change requests should refresh the map. New data, model updates, vendors, features, incidents, or regulations are all triggers to recheck obligations, controls, evidence, gaps, and residual risk. This is how mapping connects to release gates, security review, audit planning, and accountable governance. You now have the core map. Obligations connect to AI risks, controls, operations, and evidence. Strong mapping starts with clear scope, shared ownership, and artifacts teams can actually use. Audit readiness is built continuously. Next, we define the system itself through inventory and data flow baselines.